Hello guys and welcome. I hope that you're doing well. My name is UHD King, or I play 4K, AK, I play 8K, AK, I play 16K, and during this video I'm going to demonstrate Dota 2 PC game running in 16K video resolution, 16K UHD, 16K gameplay, 16K gaming with the help of two Titan RTX video cards and SLI and Intel Core i9 9900K overclock at 5.1 GHz, running only physical 8 cores and 8 physical threads. Hyper threading technology is disabled in the BIOS. This is going to be the world's first Dota 2 PC game running in 16K video resolution with more than one video card. I was the first YouTuber that demonstrated for you 16K video resolution in Dota 2 PC game all the way back in 2020 with my Xeon E5 2697 V2 CPU, but with a single Titan RTX video card. I also demonstrated on the same system i9 9900K with single Titan RTX video card in 16K UHD all the way back in 2022. I'm going to attach those videos and video comments down below if you're watching it on YouTube, so you can watch it and you can compare the performance, the same system, but today we are running two Titan RTX video cards in SLI, Nvidia two-way SLI. And by the end of this video, I'm going to show you how to set the custom profile, SLI profile, that is working in Dota 2 PC game with 2, 3, or 4 NVIDIA video cards that supports NVIDIA SLI, as well as I'm going to demonstrate it, all the description and specification of the system that I'm running today, and some more technical details about 16K video resolution, 16K UHD video resolution. Alright guys, so throughout this video we're going to test all kind of different visual presets. Let me go ahead and open up just to demonstrate for you. Keep in mind that my desktop is set to 16K UHD. At the end of this video I'm going to go ahead and demonstrate it for you. So right now I'm going to show you the maximum visual preset without the anti-aliasing. Then I'm going to show you the maximum visual preset within the anti-aliasing. Then I'm going to show you the maximum visual preset. Ambient occlusion will be off. Ambient occlusion takes in a lot of FPS, over 10% of the FPS performance on Turing GPU architecture. So ambient occlusion in 90% games that I tested is pretty much a big deal, especially in 8K video resolution and above on Turing GPU architecture. And today we're running a flagship video card of Nvidia Turing GPU architecture, such as Titan RTX. Sometimes people saying RTX Titan, but it's incorrect. Titan RTX that is equipped with 24 GB of GDDR6 unregistered with no error correction video RAM per video card. We're running two of them in SLI, two-way SLI. So let me go ahead and get going, guys. Maximum visual presets, 15,360 times 8,640. As you can see, my Nvidia driver is hacked, so I have all the resolution unlocked, and it's thinking this is the native resolution. Even if I'm not putting the signal to 8K UHD native screen, it doesn't matter. It's still going to render this in 16K video resolution because Windows 10 professional operating system, including Nvidia drivers and Nvidia shadow plate, thinking that I'm running in 16K video resolution. By the end of this video, I'm going to demonstrate to you the facts. I'm going to run display mode and borderless windowed mode. The reason why, because in the future, I'm going to use Dota 2 PC game. And as a benchmark, I'm going to test on all kind of different CPUs, on all kind of video cards, all kind of PC systems, including the mobile devices such as iOS devices by Apple and Android devices. So borderless window will be the best while running all kind of different rendering APIs to compare the performance and see how the future tech improved versus today. But keep in mind that Titan RTX video card and Intel Core i9 9900K is a technology that was available to us since 2018 to purchase. But I was so busy with all kind of different 16K UHD video resolution benchmarks, so I didn't touch it with the two Titan RTX and SLI, and today is the date. All right, so let's go ahead and do that. I'm going to apply that. We're gonna apply that, and I'm going to play the same demo as I did in 2020 or 2022 in 16K video resolution on a single Titan RTX. By the way, as again, I'm going to attach that video for you to compare. I click watch now, replace, and that demo will be, I'm going to also upload the demo for you to try it out because I really like this demo. It's in the International 2019 Championship, a grand final. OG versus Team Liquid in Dota2 PC game 4 out of 5 on $34 million championship price in prices, a grand final. And I really like this demo because at the beginning there is a lot of action going on. It's nice to use it as a benchmark, and we're going to use this demo in the future as a benchmark. I'm going to upload this demo so you can download it and put it in your replays folder under the Dota2 PC game and test it as well. Alright, so we're going to click on that. So maximum visual preset, 16K video resolution with no anti-aliasing. I'm going to use the English commentator, which is T19 English, and I really like him because we're gonna use his camera. He's gonna follow the camera, and I really like his camera. Jump to the game. I smashed that button, and we're gonna go exactly to the game right now. You want to keep your eye at the left top corner. Data updated every single second, verified every single value of those variables, correct, dynamic, and exactly what it is. So you're gonna see 26, 30, current 30 is the maximum, 34, 37, I just saw 37 is the maximum, and video RAM utilization is almost 16,000 megabytes, as well as system RAM utilization is below 14,000 megabytes, but it's gonna grow as well. Two Titan RTX is running completely stock, but fan rotation running 100%. I'm using CPU artificial intelligent voice cleaner, so my voice can be disturbed a little bit because it's removing the noise from the audio recording. I'm recording in real time. This video will be a single take, the way we're gonna go, the way we're gonna see it, and I'm not gonna edit this video. I'm also hack or modify my Nvidia drivers and Nvidia shadow play, so it's recording on Nvidia Turing GPU architecture in 8K UHD. Even if Nvidia introduced recording 8K UHD through the Nvidia shadow play with the RTX 40 series video cards while using AV1 video codec, it's still possible on Turing GPU architecture as the first GPU architecture by Nvidia to encode in real time in 8K video resolution while using Nvidia shadow play. They just didn't introduce it, but you can modify it. Maybe in the future I'm going to show you how to do that. And it's recording 8K UHD, so please watch on your YouTube player in 8K UHD 4320p, or as minimum switch to 4K UHD to see the difference, which is 2160p. Otherwise you're not going to see too much of the difference. Okay, beautiful FPS. As you can see, MS at the FPS at the left top corner stands for the milliseconds. It's going to be a latency delay before each frame is rendered. So to have stuttering free, lag free experience, you want to be below 10 milliseconds. The low value is better, no matter what is your FPS. But MS value generated from the FPS over 120 FPS will be below 10 milliseconds. So this is where there is no stuttering and no lag free, below 10 milliseconds, but all the way till 15 milliseconds, almost no stuttering, no lag. Above 15 milliseconds, all the way to 30 milliseconds, this is when stuttering starts and lag starts. And above 30 milliseconds, this is when you're going to feel the lag and stuttering, especially above 300 milliseconds, completely animated frame rates, not even gameplay. So two Titan RTX video cards, as you can see, guys, didn't bring us the double value in terms of the FPS, but at least 10 FPS higher than it was on single Titan RTX, which is great because the GPU utilization, as you can see at the left top corner, sometimes getting for both GPUs below 70%. And we want to have each GPU at 99-100%. This is exactly why we're gonna use all the Nvidia CUDA cores that is featured in our GPU. So nothing will be idling, nothing will be wasted, and maximum performance out of those GPUs will be generated. It's not the case, as you can see. SLI is not perfectly. The reason why, it's not because the SLI provided. The reason why because this CPU cannot handle two Titan RTX video cards with the 9216 CUDA cores total, which is 4608 CUDA cores per GPU. It had no problem with the RTX 2080 Ti video card, which is same Turing architecture, the same Nvidia TU102 GPU. However, RTX 2080 Ti video card TU102 GPU is hybrid TU102 GPU. Due that it's 256 CUDA core less than Nvidia TU102 Turing GPU architecture that featured on Titan RTX video card. It's going to be 256 CUDA core more per GPU. So two Titan RTX video cards in two-way SLI by Nvidia will feature 512 CUDA core more than two RTX 2080 Ti video cards in SLI. Keep that in mind. And it's a lot. It's like one RTX 2060 video card more on two RTX on two Titan RTX in SLI versus two RTX 2080 Ti in SLI. Keep that in mind. So our CPU, which is Intel Gen 9 flagship Intel i9 9900K, even when it's overclocked to 5.1 gigahertz from 3.6 to 5.1 gigahertz with 8 physical cores, cannot handle this 9216 CUDA cores, and it's pretty much bottlenecked through the CPU. It's not enough instruction per clock, overall instruction per clock. Okay, by enabling hyper-threading technology, which is 2.7 hyper-threading threads is equal one physical thread. They're slow, and they're not going to give us the additional bandwidth. Maybe just a little bit additional bandwidth, but it's not going to increase the load on the GPUs. So to increase the load on the GPUs all the way to 9900% per GPU, you want to have better CPU with instruction per clock. Keep that in mind. And I saw that a lot in a lot of games, in old school games. I cannot fully maxed out two Titan RTX video cards, while I had no problem to max out two RTX 2080 Ti video cards in SLI. And the reason why, I believe, because the Intel i9 9900K not fast enough even at 5.3 gigahertz. I believe this CPU will be fast enough if artificially will increase instruction per clock through the increasing the impulsing on the CPU through the overclock. And to be able to do it, I think 7 gigahertz per each core will be more than enough, but it's unachievable for the CPU. You're gonna burn it out. So 5.3 gigahertz is a maximum home safe environment frequencies for the CPU to the overclock, and use the massive water cooler for that, and it's not enough. So you better use the newer GPU with the same frequencies, but that capable to push with the same frequencies newer generation of the Intel or AMD CPU that is capable to produce more instruction per clock. So your CPU utilization will be higher. But there is a problem with that, because the Intel and AMD chipsets are no longer supporting SLI certified license on the chipsets, because Nvidia pulled out after 2018. So after 2018 chipset doesn't support AMD and Intel SLI certified. You can still enable it by modifying the driver, but there is a huge process and it's not guaranteed. I never tried that though. But if you're gonna put two video cards and connect them with the SLI bridge, it's not going to work on the on the motherboards on the AMD or Intel CPUs after 2018. Keep that in mind. All right, so we'll look at that. It was excellent performance. All right, so I'm going to go ahead and do now the anti-aliasing. I'm going to reboot the game. I'm going to reboot the game every single time. I'm going to switch the visual preset. The reason why, to clean the garbage collector through the game engine, just some data while in the visual presets that's not going to be used at that particular visual preset. In case if the game engine is not going to throw it away, we're going to do it by rebooting the game. So anti-aliasing is on. I'm going to go ahead and reboot the game. I applied the settings a couple times. We're going to real quick reboot and restart the game. I'm using the Dota2 Steam version. As again, in the end of this video, I'm going to show you how to create custom SLI profile. But if I would have two GTX 1080 Ti video cards in SLI with the Intel i9 9900K, it would scale perfectly, guys, at 99% per GPU on those two video cards on each GPU. Trust me. But during GPU architecture, especially Titan RTX, is too much in terms of the CUDA cores for this CPU to handle. But RTX 2080 Ti was scaling first GPU 97% while second 99%. But additional 512 CUDA cores, it's like RTX 2060 video card. It's just so much for this CPU to handle. Hopefully guys this makes sense. As again, today is July 22nd, 2023, but this type of technologies was available to us all the way in 2018, in December 2018. Let me double check real quick the visual preset. Yep, visual presets are here. As again, this video will be unedited and I'm coming in real time, which is the best way to share the experience. As a senior system engineer, PC overclocker, PC hardware enthusiast, PC gamer, graphics designer, 3D artist, 3D animator, a lot of experience I can share as a software developer and game developer as well. So no matter what kind of industry you're coming, you're gonna learn a lot by watching this video. This video is not going to be as fast as possible, but this video is going to be as formative as possible because I'm a pioneer that running the first 16K UHD gameplays, 16K UHD video resolution, 16K UHD gaming on YouTube. So I better share that data, that information with you guys, so you will know exactly what's going on and you're gonna build much better system in the future. Because right now in 2023 you can buy yourself 4 8K screens and stitch them together and create 16K UHD video resolution array. And if screens will be 85-inch each, it's going to be an amazing experience, over 340 inches on the whole wall in your house. It's unbelievable experience to play Dota2 PC game in 16K video resolution on 340 inches screen. It just, even 4 of them 8K UHD is just unbelievable experience. Stitch them together, believe me guys. Alright, so anti-aliasing is on, maximum visual, 16K video resolution. Let's go and have a look, shall we? Trying to provide so much value, but you know, not just because I like to talk, but just because I need to provide it to you guys. I have to provide it to you, all this data, a lot of data provided to you. You're watching the future, you're watching at least 2027, but I would say 2030 for the regular gamer, when 16K video resolution will be top of the line video resolution for PC gaming. Before, PC gaming will be dead because everybody will be switching to the mobile devices, to the AR glasses, while 3D will be combined with the 3D, and holographic screens will be also popular in 2027, 2030. But if you're watching this video in 2027 and still don't have 16K video resolution screen, but watching it on 8K UHD, go ahead and smash that like button. Let me know your experience down below. But 2030, this is where the top of the line 16K UHD will be out there for about $5,000-$10,000, and top of the line gamers will be having it. But I'm showing you guys the future, and I showed you the future as UHD King all the way since 2016 over UHDking.com YouTube channel, so you know what's up. And yeah, you're watching the future guys, and a lot of time, money, energy is invested. So go ahead and smash your like button, share it with your friends, subscribe for more great videos, valuable videos in the future, and watch my ads. I'm gonna collect those pennies. I'm gonna buy some new hardware. I'm investing back into you, as again I'm running on my own expenses. Nobody support me, and it's like thousands of dollars to be able to show you this experience. And sometimes I also giving some games away on Steam, Origin, Epic Games, and GOG. So support me guys, and great YouTube channel, unique YouTube channel, not one of those copycats. So I'm looking for your support. People doesn't know that 16K video resolution is available, but show it to them, and subscribe guys. In the future, it's a lot of gamers will subscribe to my YouTube channel, but right now not too many people even aware of 16K UHD gaming. So go ahead and subscribe, support me guys, and let's build this 16K UHD community together. So as you can see, almost 16,000 megabytes of video RAM utilization. System RAM utilization is also almost 15,000 megabytes. FPS is great, like 30 FPS average. I just reset the FPS, but current is above than 30 FPS. Titan RTXs are pretty much thermal throttle itself. Thermal throttle is a process when NVIDIA driver is lowering the frequencies on the GPU when it's getting too hot after 58 Celsius to be exact for the Turing GPU architecture by NVIDIA. And it's lowering the frequencies on the GPU, lowering the voltage because the impulsing is not as high, and it's lowering automatically the temperature through the NVIDIA driver just to keep the temperature. It cannot reach above 90 Celsius on Turing GPU architecture. It's starting after 58 Celsius on Turing GPU architecture on this particular GPU architecture by NVIDIA. And as again, Titan RTX is the flagship of the NVIDIA Turing GPU architecture, the king of the RTX 20 series video cards, much faster than RTX 2080 Ti video card, the king of the RTX 2000 series video cards, the first generation of the NVIDIA RTX generation that is available for gamers to purchase. Alright, the FPS is great. By the way, I'm gonna zoom in to show you how beautiful the game looks like. Let me go ahead and zoom in. Where's my mouse cursor? This is his mouse cursor. My mouse cursor is where? My mouse cursor, okay, it's right there. Let me put it in the middle. Right here, see how small my mouse cursor in the middle? And let me use the Microsoft Zoom tool because I'm running Windows full screen, and show you how beautiful the details and everything. As you can see, everything is not so blurry. This is 1600% zoom, guys. Look, everything is here. Let me zoom out a little bit. I'm using a lot Windows magnifier zoom tool, a lot. And check it out, this is like 300% zoom to the 16K UHD, and it's above 32K video resolution while upscale from 16K UHD. And look how everything is so sharp. Yes, indeed, we're running 16K UHD and it's rendering those real pixels, as you can see, and it's amazing. This is maximum visuals with anti-aliasing is on. This is just unbelievable, guys. The level of details, check it out, every single, and this 300% into that. I can go all the way. This is 800% right now. Check it out, everything is so sharp, and the pixels are here definitely, and yeah, everything is rendering without any blurriness, not like one of those copycats doing it. Alright, so we saw that maximum visuals at 16K video resolution, including the anti-aliasing. It was great, great, great. Let's go ahead and play with that a little bit. So what I'm gonna do now, I'm just real quick will turn down the anti-aliasing, and then we'll turn down the ambient occlusion. Ambient occlusion taxing a lot on Turing GPU architecture, more than 10%. So you cannot even compensate it through the overclock on Titan RTX video card while you're running single Titan RTX, because there is no way you're going to overclock on air to Titan RTXs in single case. It's overheating already, even when running stock. So we cannot compensate it, and it's above 10% of the performance loss when it's enabled. So let's go ahead and find out what will be the performance, and I'm going to accept that and reboot the game. So accept that 2 times. Let me go ahead and reboot the game. And just to clean the garbage collector, you already know, as software developer, game developer, and a gamer, I share the information with you why I'm doing that. And as again, in the end of this video, I'm going to show you more details about my system, about the desktop resolution natively set to 16K video resolution, NVIDIA driver hacked. All this information will be explained in the end. I decided to do it in the end, guys. So for those gamers that just want to watch how the game looks like, you can do it. But for those who's looking to get all the details, go ahead and watch till the end. Beautiful. The game looks beautiful under the 16K video resolution, guys. Especially if you're gonna have like 340-inch screen, like 4 8Ks, 85 inches. By the way, 2023, you can buy 85-inch 8K UHD Samsung OLED TV from 2021 for below $2,000. So for $8,000, you can buy 4 of them, and for $8,000, you can make 340 inches array of 16K video resolution. Unbelievable experience. If you're gonna bring your friends, they're gonna see that. They're gonna be so jealous. The visuals like on another level. A lot of copycats will doing that, guys. I just share with you some information, and a lot of people will doing that. Especially Titan RTX doesn't support 4 screens 8K video resolution in even 30 Hz because it doesn't feature enough ports, and but it can render it. But RTX 30 series flagships such as RTX 30 video cards such as RTX 3090 video card, RTX 3090 Ti video card can handle 4 8K screens at 60 Hz, and no matter what size of it, and RTX 40 series video cards such as RTX 4090 video card can handle 8K screens at 60 Hz and 85 inches will be amazing and an unbelievable experience. That video card is ready for that, guys. For the arrays, for the old school games before 2020 in 16K video resolution on 8K screens at above 60 FPS experience. This is where exactly you're going to utilize all the Nvidia AIDA GPU architecture CUDA cores of that flagship RTX 40 series video cards such as RTX 4090 video card. I don't think Nvidia will release the new Titan AIDA. They're probably going to release RTX 50 series video card, and it's going to be featuring RTX 5090 video cards will be featuring 48GB of video RAM. But for 16K video resolution, I'm advising you to have at least 48GB of video RAM, so that means no problem with your video RAMs at all. And then, of course, GPU should have enough computing performance, but usually it will have enough computing performance for that video RAM. Nvidia or AMD is not that stupid, they will include that. Alright, so this is how we're gonna do it, guys. Maximum visuals except no anti-aliasing and ambient occlusion is off. Same demo, as again I really like this demo. I will share it with you. Check the video description or video comments where you can download it, and I'm going to use this demo while I'm going to benchmark a lot of games in the future, so keep that in mind. So alright, downloads, demo, and we're going to select the English speaker and we're going to follow his camera. A lot of action throughout his camera, and yeah, let's go and have a look. Alright, I'm gonna reset the average FPS. I have the chart keys to reset it, so it's going to be correct average FPS throughout this gameplay. I'm resetting it exactly just to make sure that FPS under the average will be Gucci. Alright, so here we go. Let me zoom out. Oh, look at this. Let me see. It's doing so slow. Oh, I see what's going on. I accidentally did not 1x. Here we go. So what happened there? I'm trying to okay, I know how I'm gonna do it. I'm gonna do it like that. I didn't reset the FPS right because I pressed too many keys. Here we go. Let me see. So plus, minus. Oh, I'm pressing the wrong buttons. Here we go. Now I resetted the FPS average. So here we go. Let's probably go ahead and start it again. Let's go ahead and start it from the beginning. Jump into the game. Sorry about that, guys. I'm gonna reset the FPS correctly. I just pushed the wrong button. Sorry, there's too many buttons for me on the keyboard to push. Zoom, average FPS. Let me reset the FPS now again for you to make it so nice and beautiful. So this maximum visual preset without the ambient occlusion and without the anti-aliasing. So now the average FPS will be correct at the left top corner. That average, I gotta reset it all the time, but current is always correct. Alright, it's beautiful, guys. Still looking beautiful. This game, by the way, looks great under 16K video resolution, even lowest, everything lowest preset, but texture set at high. The game looks on another level until you're gonna touch the textures. But while you're running 16K video resolution, why you wanna run your textures anything besides maximum texture resolution visual preset? You want to run maximum textural resolution visual preset because the maximum visual preset for the texture is pretty much going to tax on your video RAM, but we have more than enough video RAM, as you can see, and 24GB video RAM or GDR6 unregistered without error correction featured on each Titan RTX, while RTX Quadro RTX 6000 video card just the same as Titan RTX video card, identical to it, except it has 24GB of video RAM that is registered video RAM and do the error correction. And the difference will be, while sometimes Titan RTX can render frame which will be black or corrupted, while Quadro RTX 6000 video card for $5,000 by Nvidia, that same Turing GPU architecture, same everything, same GPU will produce no errors. Will make sure that nothing like that will happen. So they're using it like in labs, in the medicine, in the hospital, some things like that. Because Titan RTX can do some mistakes, but Quadro RTX 6000 cannot if it has the error correction video RAM. And RTX Quadro RTX 8000 video card featuring the same GPU as Titan RTX, the same amount of CUDA cores, everything the same, only featuring 48 gigabyte of GDR6 with error correction. That one is like $7,000 when it was introduced, while Titan RTX was cost $2,500, while RTX 2080 Ti video card, which is 256 CUDA core less than Titan RTX, 10% less performance, started at $1,000 but went to $1,200, while Titan RTX was $2,500. This was the prices in 2018, guys. Okay, maximum visuals, presets, ambient occlusion is off, anti-aliasing is off. Great performance. As you can see, definitely we improved the performance in terms of the FPS versus single Titan RTX, not by double but at least by 10 FPS. Go ahead and watch that video on single Titan RTX. I'm going to include in video comments for you to watch. Go ahead and check it out, and all kind of related videos to this video in 16K video resolution tested and benchmark in 16K UHD on all kind of different systems will be attached for you in video comments. So I'm going to update it while I'm going to do the newer tests in the future of 16K UHD benchmarks. Go ahead and check out the video comments for that purposes. Alright, so we saw a lot of action at the beginning. That's why I love this demo. As again, I'm going to attach this demo, upload this demo for you in video comments. Will be linked to download. Go ahead and download it and put it in your replay folder of the Dota 2 PC game and run it for yourself to compare the performance. I'm also going to test it in 8K UHD, 10K, 12K UHD with 2 Titan RTXs and single Titan RTX on this system. And I'm going to attach the video in the video comments, the links for you to check out different type of resolution and performance for your taste, so don't miss it out. Alright, so we're Gucci here. We're done that one. So we saw the average FPS on that one. Let's go ahead and keep moving, guys. And now what I'm gonna do, as I told you, I'm going to go ahead and bring everything to the minimum possible visual preset now. Okay, so everything will be to the minimum possible visual preset on the advanced settings, but everything else I want to keep it like this. Texture at high, effect quality high, and shadow quality at ultra. Let's go ahead and run it kind of like that, and then I'm going to disable everything except the texture quality to lowest possible preset. Let's go ahead and apply that a couple times and reboot the game. Let's go ahead and do that. To clean the garbage collector, you already know exactly why I'm doing that. And as again, stick around, guys, till the end of the video. Every single details of this computer will be explained. Alright, so minimum visual preset on some settings, but not completely minimum visual preset. Let's go ahead and have a look. I think it's going to be a great thing to check it out. And as a reminder for those who's curious, this is kind of preset that we're going to run right now. So everything is unchecked except the texture quality high, effect quality at high, and shadow quality at ultra. Make sure that game screen rendering quality at 100% is very important. Otherwise, it's not going to render at 16K HD or the resolution that it's set right here. Make sure it's like that. And watch. We're going to click watch now, replace, and downloads, because I downloaded it. But if it's going to be in your replay folder on the Dota 2 PC installation folder, this is exactly where it's going to be. I'm going to click watch it, because they're going to remove this championship. But as again, this championship was amazing. $34 million just for that championship and prices. Too bad I'm not Dota 2 PC gamer, but you know, it's a great game to play. A lot of prices. But I'm benchmarking Dota 2 PC game on all kind of different systems over the UHDking.com. So if you're Dota 2 PC gamer, if you're Dota 2 fan, this is the YouTube channel for you to watch. If you buy a new computer, to understand which will be the best option for you. Alright, I just reset the average FPS. So average, look at this, over 50 FPS. It's running so nice right now. So as I explained to you guys, the ms stands for the milliseconds, latency delay at the left top corner by that FPS. So it's before each frame is rendered. This is how much this millisecond takes. So 1 second is 1000 milliseconds. So your brain is not register everything below 10 milliseconds. It's kind of hard for average person to register it. So it's no lag or stuttering free after 10 milliseconds or lower. But about 15 milliseconds where your brain starts registering some stuttering and lag, especially above 30 milliseconds, and if latency delay above 300 milliseconds, it's like a slideshow. You can see it clearly. It's like 3 frames per second. Look at that, 67 FPS. That's like, this is right now, this is a playable for a lot of players. It's a playable, comfortable status for a lot of old school players. Way above benchmarkable status, way above just a playable status. It's a playable, comfortable status already for a lot of gamers out there, because the latency delay is like 15-16 milliseconds, below 20 milliseconds. A lot of people can play that, that's for sure. Especially old school classic gamers, PC gamers. Alright, so we can see the video RAM utilization is almost 15,000 megabytes, but below 15,000 megabytes. So if you remove some presets, maximum visual preset will lower that video RAM down a little bit. Even if we have enough video RAM, I'm showing you the video RAM statistics for the future video cards, so you will know exactly if Dota 2 PC game is your game, how to build a proper PC to play this game at your proper resolution. That's why I'm showing the data. System RAM below 14,000 megabytes, as you can see. Great average FPS, this is unbelievable, and great current FPS. And great, by the way, great visuals, maximum visuals, but texture is still at high. It's looking just unbelievable. Let me go ahead and zoom in and show it to you guys. Let me show you how beautiful. Where is my mouse cursor? The mouse cursor is such a small, I cannot allocate. Oh, right there. Cannot allocate it. Here we go. Let me put it in the center. Let me zoom in for you. So this is going to be 300% zoom. This is 400% zoom. Look how everything is so clear onto this 16K video resolution. Everything is here without any blurriness. Everything is so detailed. Please watch this video as again on 8K UHD through your YouTube player. Switch it to 4320p or 8K UHD, or as minimum 4K UHD, which is 2160p. But 8K is maximum visual experience because I'm recording with Nvidia Shadowplay at 120 megabit per second in 8K UHD, because as again my Nvidia driver is hacked, Nvidia Shadowplay is hacked, and Turing GPU architecture is the first GPU architecture that is capable through the Nvidia Shadowplay to record 8K UHD. Maybe in the future, if a lot of gamers will smash that like button, I'm going to share with you how to do that, how to hack Nvidia driver, how to unlock an extra capabilities without any harm to anyone. Look, everything is so beautiful. This 400% into 16K video resolution, those pixels so detailed. So imagine if you're going to have 340 inches screen, it's going to be so detailed, so beautiful, so nice. Alright, so we saw the FPS, we saw everything that we need to know. The video RAM was below 15,000 megabytes. The system RAM also almost reached as same as video RAM, but was still below 15 gigabytes or 15,000 megabytes. Alright, so we saw that. Let's keep moving. Let's go ahead and keep moving. That's more than that. Oh, the game crashed. Alright. It happens because I have the high overclock and Titan RTX kind of overheating. I did increase the voltage on them. It's nice when you're increasing the voltage, but it's gonna get too hot. And let's go ahead and run it again. And plus I'm recording in real time. I'm stressing right now. The GPU is like unbelievable. I'm recording in 16K video resolution, running the system, and recording in 8K UHD. So when I'm recording, sometimes it's crashing when I'm recording because so much stress on the system. It's unbelievable. Especially everything is running so hot. I'm running technology from 2018 and I'm pushing, like showing you 2030. It's just unbelievable. Alright, so what we're gonna do now, everything will, but texture quality will be at high, but everything else at minimum, as you can see. And I'm going to go ahead and do 16K video resolution, apply that couple times, and we're gonna go ahead and reboot the game just in case. Let's go ahead and do that. And right now, as everything is minimum except the textures. Texture running maximum visuals. But as again, what's the point to play 16K UHD while texture at low? But I'm also going to show you texture at low, and then an extra bonus. I'm going to show you everything at low, every single value at low, but with anti-aliasing. For those people that was asking me to see the relationship between the CPU and GPU, and extra data and extra information on the maximum visual experience in PC gaming that is capable with the 3D rendering, real-time APIs, no matter what it is, commercial or open source APIs. It is what it is. So as again, this is the visual presets. You already know what's up, right? Everything at minimum possible visual preset except the texture quality at high, and the game looks amazing with texture quality at high when you're running 16K video resolution. Right now it's going to look just like 4K HD set at maximum visuals, because as again 16K video resolution bringing that amount of pixels and bringing that level of details even at lowest possible visuals to another level. Look how small that Nvidia Shadow Play icon right there, the green at the bottom right corner. This is unbelievable. Alright, English commentator. I'm gonna jump into the game, make sure that FPS, average FPS is reset. Let me push the hotkeys for that. And let's go ahead and have a look, guys. Let's go ahead and have a look. It's definitely going to be nice to see what's up over here. Alright. Oh, look at that, crazy. I just saw about 67 FPS was a couple seconds. That was unbelievable. It's unbelievable now experience. As you can see, below 15 milliseconds latency delay at some point when the FPS like above 60 FPS. This is right now is playable, and this is looking unbelievable well, because as you can see the detail is still here because the texture is running at high, the texture is running at maximum visuals, but every single other preset at the lowest possible visual preset. But when you're running Dota 2 PC game under 16K video resolution, when everything turned down at lowest possible visuals but textures at maximum under 16K video resolution, we're loading all the pixels, details, guys. Oh yeah. Let's go ahead and zoom in into this character right here. Let me put it in the center. Where is my that? Check it out. How beautiful. This is 400%, 500, 600. Look, the details are everywhere. Details are here. The textures, pixels are not blurred out. If you're gonna do something like that with 4K UHD, everything will be so blurred out. But over here, everything is so nice and beautiful. This is just unbelievable, guys, and level of detail. So you can play it like that. The visuals look like 4K UHD at maximum visuals. The visuals are on another level. This is just unbelievable, guys. This is just unbelievable. The FPS is unbelievable, well over 80 FPS, the current I just saw. And there is right now a lot of action going on, like 5 players playing, and it's like unbelievable, over 70 FPS average. This is just unbelievable. As again, guys, the audio track is all right reserved. Patrick Patricius, Beyond. And today we're definitely running Beyond 8K UHD, as you can see, and beyond everything what you can imagine, beyond a single video card. The first video card that is capable to render this game in 16K video resolution, the first gamer's video card. As I explained to you, the Quadros was a little bit on another level on the Turing GPU architecture, because Quadros was featuring actually 48GB of video RAM registered and error corrections, such as Quadro RTX 8000 video card. The same GPU as Titan RTX, the same amount of CUDA cores, but the video RAM can push it above than Titan RTX under the 16K video resolution when the Titan RTX is overloading the video RAM. But for this particular game, we never overloaded the video RAM, so we are Gucci. But RTX 2080 Ti video card or RTX 2080 Ti and SLI couldn't run this game in 16K video resolution at all kind of visual presets, because it's not going to feature enough video RAM. It's going to overload the video RAM and crash the game, because RTX 2080 Ti video card featuring only 11GB of video RAM, but almost the same performance as Titan RTX in terms, because the same Turing GPU architecture. But Nvidia TU102 GPU, that is hybrid version, featured on the RTX 2080 Ti video card, because 256 CUDA core less than real TU102 GPU that featured in Titan RTX, the Quadro RTX 8000 video card and Quadro RTX 6000 video card, which is the flagships. Alright, so we saw that, guys. We saw that. You saw everything that you need to know, right? Let me go ahead and keep moving. So now I'm going to bring the textures to low. Now it's going to look ugly, but still under 16K video resolution, not so ugly as under 4K video resolution, because it's going to limit some pixels through the artificial intelligence algorithms and not loading all the pixels of the texture. But it's still going to be great because it's going to load a lot of pixels, because that little models, 3D models that running on screen under 16K video resolution will be big, and the amount of pixels not like so small on your 4K UHD. So we're still going to be better than 4K UHD, but not as good as you just saw when textures was set to maximum visuals. Alright, so let's go ahead and bring it up. Everything right now is set to the minimum, but still without the anti-aliasing, and the last preset will be everything at minimum, but anti-aliasing will be at on. Just for those people that was asking me to do that, this is going to be an extra bonus for you. Don't forget to smash that like button. I'm sipping the hot coffee with the organic honey, guys. Hopefully you're doing good as well. Go ahead and sip some nice healthy drink, tea, water with the lemon, the healthier, or some coffee. Do not drink too much coffee though, but lemon is a great thing to put in the water, guys, to clean your body. Anyways, let me go ahead and remind you, for those people who just jumping in this part of the video, that everything will be at the lowest possible visual preset, 16K UHD. My desktop set to 16K UHD. And this is how we're gonna run it. Make sure the game screen rendering quality is 100%, so it's going to be 16K UHD or whatever the resolution set here. Okay, and as again, this is going to be without any editing, guys. There is no way for me to lie, to manipulate. What's the point? I'm here to provide value, and this is the point on my YouTube channel when it comes to gaming videos. I'm trying to show you some sophisticated computer science videos, even when it's including to the gaming videos. Alright, so let's go ahead and execute that. Minimum possible visual preset. English commentator. Jump into the game. I'm going to make sure that I'm going to reset the short keys for my average FPS. We're going to increase the CPU load right now to the maximum possible load under 16K video resolution. The higher resolution, the less CPU load, keep that in mind. But the lower visual preset, the higher CPU load as well, keep that in mind. But higher visual preset, the less CPU load, but higher GPU load. The higher resolution, the less CPU load, but higher GPU load. This is the rule, guys, that I learned as the first pioneer that did 8K UHD all the way back in 2014. 8K UHD since 2014 over UHDking.com, guys. Look at that, above 88 FPS I just saw. That was unbelievable current. That's just unbelievable experience right here, guys, going on. This is definitely playable experience, and everything doesn't look too ugly. It's lookish like your 4K almost at medium. Check it out, it's looking great, because as again 16K video resolution, bringing that amount of details, unbelievable amount of details. And let me zoom in, actually show you how it's lookish under this 16K video resolution when we're gonna do. So mouse cursor at the center. Here we go. While we're gonna do like some crazy zoom through the Windows magnifier. Look at this. This is how it is. Still rendering great amount of details, great amount of pixels, but not as good. Right now it's a little bit blurred out, not as good. But that was like 800%. This is 400%. Check it out. 400% into 16K video resolution, still great, because as again it's rendering 16K video resolution 3D surface 3D world. That's why, and it's just looking great, guys. This is just unbelievable. A lot of action going on. You saw the FPS 7980 FPS, but just because I'm recording with Nvidia Shadowplay, without recording with Nvidia Shadowplay in real time, go ahead and at least 3 FPS to the FPS corner, you will be Gucci. It's like 7%. But I would say 3 FPS you will be Gucci without the recording the Nvidia Shadowplay, just doing the same benchmark. Alright, guys, so we saw that. Let me go ahead and quit that, and let me quit this, and now I'm gonna do the last task, which will be before we're gonna talk about the PC computer specification of my system and some more details, and why 16K video resolution, not 16K UHD, but why 16K video resolution is the maximum visual resolution that can be rendered in 3D in real time through all commercial and open source API that is available in 2023. I believe it will be the case 2025 and even 2030 before the PC gaming will be phased away, because the mobile gaming will be replaced, such as mobile devices, iPad and tablet Androids will be replacing that, and also people will be using a lot AR glasses, while 3D combined with real life. I do not believe in VR technology, but I believe in AR technology and glasses and holographic screens. This will be 2030, but if you're watching in 2027 still don't have 16K video resolution, go ahead and smash that like button. Most likely you're watching it on 8K UHD screen. Smash it to your like button, positive comments, guys, and support me. Alright, so what we're gonna do now, minimum visual preset but anti-aliasing is on. This is, a lot of folks was asking me, like over 5 people, over UHD King, my subscribers. This is for you. Don't forget to smash that like button. As again, DirectX 11, as you can see, Vulkan API or DirectX 11 API is available. So all the presets, as again, Nvidia drive was hacked. Alright, so let's go ahead and restart the game. This is going to be the last test real quick, just to show you relationship between the CPU and GPU under 16K video resolution, minimum visuals, but anti-aliasing is crack on. Let's go ahead and have a look. In this particular game though, that running the Valve game engine, and this game engine is, you can see, more like CPU related versus the GPU related, because as again, it's designed for the people with the laptops, people with not high-end video cards, people with a low budget, and designed for a big population to play this game. That's why. Their strategy was to have as many gamers as possible, not to have the best experience, but as many gamers as possible. But they featuring great prices on every single championship. As again, you just watched the demo that was featuring $34 million just for the championship in 2018. But maximum amount was $44 million, maximum price ever in Dota 2 PC game, which is the record for any PC game on championship or grand final or any prizes in the game, just for a simple championship. Alright guys, so that's how we're gonna do it. As again, let me smash that apply for those naysayers. So minimum visuals but anti-aliasing is on. Let's go ahead and have a look. As again, just for those, check out the SLI utilization as well. So a lot of value, a lot of data is provided. As you can see, the key is to provide as much information as possible, be as informative as possible. As pioneer of 16K UHD benchmark, 16K UHD gameplay, 16K UHD gaming, as UHD King, you know exactly why UHD King, guys. Now, alright, so English speaker, and we're gonna follow his camera, and yeah, this is the last bonus. Stick around, we're gonna talk about the system for those newcomers. A lot of information will be provided to you. Alright, right now the maximum CPU utilization will be bought, as well as going to be a little bit hardcore on SLI, not too much hardcore, but because they're anti-aliasing. So look at that FPS. You better play with the high textures. The same, the video RAM utilization is very low because the texture is at lowest visual preset. But we're not struggling in our video RAM. We have 24 gigabyte of video RAM. We still have like 10 gigabytes to go. So you better play with the maximum visuals on the textures, because in terms of the FPS there is no big difference. The same FPS, as you can tell. And even with the anti-aliasing on, maximum visuals, maximum textures, anti-aliasing on is how I would play this game, because the SLI utilization not so bad. As you can see, 95%, 96% for GPU 2, which is great, by the way, and great FPS. So this playable experience under the 16K UHD video resolution, 132.7 megapixels rendered in real time, NASA video resolution. This is unbelievable, guys. 133 megapixels per every single frame rendered in real time while processing the 3D shaders, compilations, and all of this computing. This is unbelievable. Let me zoom in, show you how it's lookish. So lowest possible visual preset. This is 200%, 300%, 400%. Oops. Look. Yeah, some details blurred out because the texture is running lowest possible visual preset. As you can see, the horse is not so detailed, blurred out, but still not so bad at the distance. But when you zoom in, it's bad. But as again, you get to that type of zoom in. You gotta, if you only build 4 8K screens as array of 16K video resolution but 340 inches tall array, then you're gonna see, then you better smash your texture to the maximum visuals. Anyways, guys, you saw the FPS, you saw everything what you need to see. I think we're gonna go ahead and wrap it up at this point. So this is done. This is done. Everything over here was discussed, was showed to you in the proper way. So the first thing first for those naysayers. By the way, in the background, this is my system, exactly my system, how I was running 200 millimeter cooler massive fan just to get that hot air pocket from between the two video cards, because the first video card closest to the CPU is hottest. CPU is water cooled with the Corsair H150i Pro. That comes with 360 millimeter radiator and 3 Corsair fans. What else? Titan RTX is running completely, as you can see, Founders Edition era coolers, dual fan, EVGA Turing GPU architecture SLI bridge, which is NVLink, Nvidia NVLink. That used today for SLI. I use the same one for the RTX 2080 Ti in SLI videos, and yeah, this is what's up, guys. And let me, first of all, let me zoom in and show you. Let me zoom in and show you. First thing first, my desktop is set to 16K UHD. While you're running Windows full screen mode, this is very crucial. So display settings, look at this, 500%. So 100% scale, 15,360 by 8,640. Try to zoom in something like that to 1600% of your Windows magnifier zoom tool. By the way, this tool is very handy and using it a lot when I'm using the desktop in 8K UHD and above. Even if you have in the 85-inch 8K UHD screen, you better use this magnifier tool. But when above 8K UHD, you better use that. That's definitely handy. So look at this, everything is so sharp. Try to zoom in like this using this tool on 4K UHD screen. Everything will be so big, pixelated and blurred out. Over here everything is so sharp and nice. Everything is right. Okay, let's go ahead and close that. The next thing you all, GeForce gaming experience. Let me show you. I confused the Nvidia driver. So under the GeForce gaming experience, right, make sure that this says like that under Dota2. It's loading, as you can see, like that. This means that you exactly running exactly what you're running. Window borderless, right? Resolution 15,360 times 8,640. Look at this, our latest piece that we used. Make sure that it says something like that, but we can full screen 4K. So make sure it says like this under the GeForce experience right here. Okay, see that under the Dota? Yeah. So indeed, GeForce experience Nvidia was confused and it was rendering in native. It doesn't say the legacy, because if it's going to render DSR, it's going to say legacy DSR or legacy in parentheses, but it doesn't do that, because the newer DSR will be using artificial intelligence, and the old DSR such as DSR since Maxwell GPU architecture, such as Titan X Maxwell GPU architecture. By the way, I have a lot of coverage on 4 Titan X Maxwell GPU architecture in SLI, Nvidia 4-way SLI that you don't want to miss over the UHDking.com if you're into SLI. 4 Titan X Pascal XPs, Titan XPs, and SLI. Go ahead and check it out, guys. But it doesn't say legacies. Those video cards, including the Turing GPU architecture, when it's using DSR, it's using the legacy DSR without any AI involved, which is artificial intelligence, and it's rendering like native. A newer DSR will be using the AI, but it's going to say legacy DSR or not legacy DSR. It's going to boost up the performance. It's still going to render just like a native, but some of the frames will be rendered using the artificial intelligence while predicting the pixels. So some of the frames will be blurred out while upscaling through the AI while predicting the pixels, but not all of them. So it's still going to be the picture quality using AI by Nvidia. not the legacy, the newest one that they introduced on RTX 40 series video cards, such as RTX 4080, RTX 4090 video cards, RTX 4070 video cards, will be using the AI. So that means the Nvidia is predicting some of the frames while it's going to predicting the pixels. So one of the pixels will be upscale predicted, but some of them will be natively rendered. So it's going to boost up the performance in terms of the FPS for the same type of GPU computing performance. Keep that in mind. In terms of the FPS, will be boost up. All right, so this is the system, guys. This is the system that was running. As you can see, MS Afterburner Titan RTX was synchronized, running 100% fan rotation. Look at this magnifier zoom tool, 900%. Let me zoom into 1000. Try to do something like that. Everything will be so pixelated, so blurred out under the 4K HD screen resolution. Yes, indeed, and everything is so sharp over here. Yes, indeed, I'm running 16K UHD pixels details just the way it should be for 16K UHD video resolution. Alright, the true 16K video resolution experience, 16 divided by 9 aspect ratio. So 8 physical cores, 8 physical threads, 5100 megahertz as external frequency because using 51 multiplier and 51 multiplier for the AVX to instruction frequencies as well. So AVX to instruction frequency 51 multiplier. That's why my FPS did, my frequency on the CPU cores didn't jump. It was exactly locked at 5100 megahertz because the nature for the Intel Core i9-9900K to jump the frequencies from the external maximum frequencies to the AVX2 instruction frequencies, because by default through the Intel driver, AVX2 instruction frequency when it comes to Intel Gen 9 CPUs are lower than maximum external frequency. Keep that in mind. But mine was synchronized, the best possible experience. By the way, I'm going to have the best overclocking tutorial for the Intel i9-9900K. So if you're building the proper systems, PC systems from the used parts, which is the best way to build the systems, especially for the low budget. Don't think about low budget. This is the proper way to build the system from the used parts. You don't want to miss my tutorial how to overclock the Intel i9-9900K if you're building a system with the Intel i9-9900K. I'm going to show you all kind of secrets that nobody shared with you over YouTube because they were copying each other, but I'm gonna show you all the secrets for all kind of different scenarios to achieve the best possible performance. Over the UHDking.com, I'm doing the best tutorials on overclocking video cards, overclocking CPUs, so make sure to smash that like button. As again, guys, a lot of information provided to you, a lot of time, money, energy is invested. Instead of investing my time towards making money, I'm investing towards providing the information for you so you can build a better PC system, so you can be a better computer scientist, better PC gamer, better PC hardware enthusiast. Don't forget to smash that like button, guys. Share it with your friends, positive comments, and subscribe for more great videos. So as you can see, I was using Z390 chipset, Asus Maximus Hero Coffee Lake chipset by Intel, and 3200 megahertz, 1600 megahertz times 2, 3200 megahertz as external frequency, but not CL16, not CL14, not even CL13, CL11. The rollover value is better for the latency command. So usually one step down on CLs is equal to 200 megahertz when it comes to DDR4 compensation if you would be running higher frequency. 4 sticks, 8 gigabytes each. Dual channel means 128-bit. It's ready for quad channel 256-bit, but Z390 chipset supports only dual channel. It's not the server platform, and it's 40 gigabytes per second bandwidth and support for the CPU. But I was running above of that. As you can see, I was running 48, 47, 46,000 megabytes per second, or 46 gigabytes per second, at least 4 gigabytes per second bandwidth higher than this CPU is designed for, because I overclock the CPU and I overclock my memory by lowering the latencies to the lowest possible and overclock my cache frequency on the CPU with 48 multiplier versus 36 multiplier, which brought 4800 megahertz or 4.8 gigahertz of the cache frequency of level third cache frequency that shared on each core, which is boosting impulsing higher. Also give us the NS over here throughout this benchmark stands for the nanoseconds. The lower value is better, just like MS on the throughout the benchmark 16K UHD benchmark. As you saw, MS milliseconds, NS is nanoseconds, even faster than milliseconds. All right. So of course I was using Corsair DDR4 5000 megahertz, the fastest possible DDR4, but it's unstable on Z390 chipset. Corsair claim it's only stable on MSI Carbon Extreme version motherboard Z390. I have some doubts about it. I tested on Gigabyte, Asus, all kind of different motherboard MSI except the Carbon Extreme. I have some doubts about it, but I'm going to build the future system Intel 14 Gen CPUs. It's going to be Intel 14900K i9, and I'm going to build it on DDR4 platform Z690 chipset motherboard, while I'm going to utilize this memory DDR4 Corsair DDR4 5000 megahertz, and we're going to find out if it's supporting 5000 megahertz or not at CL18. It doesn't support any 5000 at any CL, not even goes above 4000 CL18. If you're having the same memory, let me know, guys, in the comments below if you're into the same problem. But I believe it's not supporting it. I believe the Corsair Lite, but we're gonna test it on Z690 chipset motherboard for the Intel 13, Intel 12 Gen, and Intel 14 Gen motherboards of DDR4 platform, because those type of chipsets Z690 supports 5200 megahertz without any question DDR4. So we're gonna find out. But Corsair lied to me since DDR1, DDR2, and DDR3 top of the line sticks that I was purchasing from them never work on the motherboards at those specs. Always was producing some errors or unstable or not even booting. If Corsair will lie on DDR4, I will never buy again top of the line system RAM from the Corsair. I better probably stick with the Samsung B chips, something like G-Skills, because it has the Micron technology chips on it, and I double check it has the Micron chipset on the sticks chips versus the Samsung B chips. And Samsung B chips, in terms of the DDR4, likes to go above 4000 megahertz, but it hates the latencies. It's also running the higher latencies. And I told you, one step between the latencies, 200 megahertz difference in terms of the speed of DDR4. When it comes to DDR4, there's very valuable information, extra information for those people that building system for DDR4. So Micron chips hates the frequencies but love the lowest latency. So I utilize this Micron chip DDR4 the best possible ways. Okay, so two Titan RTXs, as you can see, running completely stock. Okay, 24 gigabyte GDR6 by Samsung, 384 bits on the buffer on the bus. All right. So what else? Oh yeah, let me show you Nvidia control panel driver, my Nvidia hack driver as well. It's loading up. Let me show you. This is also very crucial. Let me show you the driver was modified or hacked, and through the system RAM debugger tool. The best way I learned it while I was learning the Visual Basic 6 language. Learned it in 2007. You can modify any application that running on the Windows in real time. Any values, because those values stored in the system RAM, you can modify through the special debugger applications out there. There's all kind of different applications. So first thing first, let me show you my resolution. See that? I confused the Nvidia driver. Usually it's saying the legacy DSR or DSR, but it doesn't say even the DSR. It says like Ultra HD, HD, SD, whatever. It's kind of confused, and it's 15,360 times 8,640. Thinking this is the native resolution. It was acting as native resolution, even if this is the DSR, but it was acting as native resolution. Alright, and SLI, of course, SLI was on, as you can see. Alright, two Titan RTXs for those naysayers. Maximum visual performance for the driver set to the quality instead of performance, so maximum pixel quality. And so under the global settings, so this is the custom SLI profile preset, how to set it correctly. So as you can see, DSR factor is off. Nvidia is such a confused, even if I use the DSR, but it's such a confused because I enabled the DSR and then I modified the value, but it's thinking because I modified the value over the DSR supported by the Nvidia, but it didn't crash because there is still some ways to go on that DSR, but some factors checking and make sure if it's over, it doesn't think it's DSR, think it's native. So it was acting as native, it was rating as native, but usually it's gonna say DSR legacy or DSR. If it's regular DSR, it's assuming DSR using the artificial intelligence such as AI, as again featured on RTX 30 series video cards and RTX 40 series video cards. During GB architecture, which is RTX 20 series video cards supporting DSR legacy. So without any artificial intelligence, every single frame rendered natively at that high resolution, and then downscale for your screen that outputting to the cable to see, but it's rendering. It takes that amount of performance or GPU performance to render that. So since Maxwell GPU architecture, Pascal GPU architecture, and Turing GPU architecture is rendering without any artificial intelligence involved in any frame, just every single frame natively rendered. But check it out, NVIDIA doesn't think it's just sorry when. So make sure it's maximum performance, very crucial right here. Power management, it's not under adaptive, not under optimal power. SLI rendering mode, I'm using single GPU. You can switch over here even without creating some file. You can switch over here, force alternate frame rendering 2, or sometimes it can say in newer NVIDIA drivers, force AFR2. Okay, but I didn't do that. The reason why, because when I'm running Google Chrome or Microsoft Edge browsers while using the SLI, those browsers are now coded to support the SLI, so everything is flickering there. So I gotta switch it to single GPU. I cannot run NVIDIA SLI recommended or AFR2 or AFR1. It's going to flicker the browser because the browser is not programmed to support two GPUs and doesn't know it's splitting the frames and sending and it's flickering. All right, so I only created for the browser reasons because I'm running 8K as my default resolution or sometimes even 16K video resolution. So go ahead and smash the pause button, set the presets exactly as I'm running it right now. Okay, but as again, you can set right there under AFR2 and that's it. You don't have to create the profile. But by the way, guys, Unreal Tournament 3 under 16K video resolution as the world's first video in 16K UHD for UT3 is coming out over UHD King. You don't want to miss it if you're a classic gamer. Anyways, so you want to select the Dota2 over here profile. If you don't have it, I already have it because I enabled that. But if you don't have it, most likely you're not going to have it because NVIDIA didn't support Dota 2 profile since 2016. The game was introduced in 2015, but they didn't do it in 2016 SLI profile. So if you don't have it, you got to click Add button, find the way where you install, if it's Steam version, when the Steam install the folder of Dota, select the Dota 2 executable file and click Add. And it's going to pull up some settings. So you don't need to use any NVIDIA inspector, third-party software or something like that. No third-party software. You don't need to hack your driver. You don't need to do anything. Just install your driver and just do the preset just like I'm doing it. I hacked the driver to be able to unlock above 8K UHD resolution. That's the reason why I did it. And I also hacked the NVIDIA driver to be able to record NVIDIA Shadowplay in 8K UHD native encoding through the old school codec without the AV1 codec because during GPU architecture was supporting that. NVIDIA just didn't introduce it. I believe they was holding for the RTX 30 series video card, but then they decided maybe not because maybe it was busy with some other developments, and they decided they're gonna unlock the support with AV1 when they're gonna introduce the RTX 40 series, just from marketing point of view, I believe. Anyways, go ahead and smash that pause button and do exactly as I'm doing over here. So this is how you're gonna do it for perfect SLI scalability. If you're going to use two GTX 1080 Ti video cards in SLI, guys, with the i9-9900K, they're going to be perfectly utilized 99%. The problem only with the Turing is because so many CUDA cores and i9-9900K, which is Intel Gen 9 CPU, flagship CPU, cannot handle that amount of 92 116 CUDA cores. It's just too much, but it's almost handling the two RTX 2080 Ti in SLI without any issues, almost at 97% per GPU1 and GPU2. But two Titan RTX in SLI 512 CUDA core more, which is RTX 2060 video card completely. So you can imagine. Anyways, power management, prefer maximum performance, make sure this is set. Also max frame rate, make sure it's 1000 and just in case. And background application max frame rate 200, set to the maximum just in case. So you're gonna make sure there's zero CUDA cores will be wasted while you're gonna game on in Dota2 PC game, and everything driver will force to utilize every single NVIDIA CUDA core. Anyway, power management, prefer maximum performance, and SLI rendering mode, force alternate frame rendering 2 or force AFR2. Do not select NVIDIA SLI recommended or single GPU or force alternate frame rendering 1. Select force alternate frame rendering 2, or sometimes it's going to say force AFR2. That's it. This is what you want to do. This is very crucial for that, and everything else doesn't matter, but set it the way I have. click apply. Make sure you're gonna smash that apply button, and after that point you're Gucci, guys. After that point you nail that. All right, so this part is ready. We discussed this part. One more thing before I will let you go. I promise for those naysayers, kukununus, to explain why, because most of my subscribers, most of my watchers trust me, because what's the point for me to lie? As 16K UHD gamer, the first pioneer in 16K video resolution since 2016, my point is to provide the computer science data and provide the value and make your life much better by providing the correct value. Everything what I'm providing to you guys, I'm verified, make sure everything is correct, everything is Gucci. But let me show you something. So this is the ADA64 that I did the test that you saw before. So under the ADA64, let me actually show you for the naysayers the CPU that I'm running today, 51 multiplier. As you can see, it's 95 watt CPU, 1.8 physical cores enabled with hyper-threading technology, but it's above 95. Sometimes it's reaching like 115 watt when it's under 100% stress for this particular CPU. But we never even saw above 70 watt, because I was only using 8 physical cores without the hyper-threading technology. But check it out, maximum turbo boost multiplier 51 for every single core, and it's external frequency and AVX to instruction frequency. All right, so yeah, so why 16K video resolution is maxed? So DirectX, first of all, let's go ahead and check out the DirectX. DirectX API, it's pulling the data while using the Windows 10 professional operating system, Windows 10 professional operating system utilizing that data, and it's only using DirectX 11 API 11.1 in Windows 10 professional operating system in the latest updates in July 2023. But the Titan RTX supports DirectX 12 API, but DirectX 12 API is featured on the Windows 11 operating system. Just because ADA64 Extreme pulling the data while Windows 10 professional operating system utilize the DirectX 11.1 API, even if you can run the games under Windows 10 professional operating system DirectX 12 APIs, but Windows itself, Windows 10 professional operating system itself, utilizing DirectX 11.1 API as rendering API of everything. It's no longer using 2D classes as it was using before. Okay, the developers will understand, especially Visual Basic developers, what I'm talking about. It was 2D classes under Windows XP, and even Windows Vista and Windows 7 was utilizing 2D classes, but less in Windows 7. But Windows 10 Professional fully utilizing the 3D classes. So it's like a game. It's running like a game, full 3D DirectX API surface instead of 2D surface. Anyways, so 16K video resolution is maximum texture size. Wow, this is lower on the DirectX 11 API. I'm pretty sure DirectX 12 API will be 32K maximum texture size, but any other open source or commercial API will be 32K texture size. But this is a texture size, but also for the maximum XYZ size will be 16K video resolution. It's supporting 16K video resolution as XYZ. So it's like it's saying it's shortened, saying texture size, but most likely it's DirectX surface, which is rendering 3D game or anything in 3D, sometimes called 3D surface, 3D canvas, or 3D world, depends what kind of open source or commercial API you're using. But anyway, 16K video resolution, as you can see. All right, let me show you. So this is maximum, so you cannot go above than that, because ADA64 pulling the data maximum values of those variables under the DLL files. Keep that in mind, under those classes. Developers will understand exactly what I'm talking about as a software developer. Anyways, Vulkan API, check it out, 16K video resolution, maximum 3D image size, XYZ, which is width, height, and depth. So it's a little bit above 16K UHD, which is above 15,360 pixels. It's a little bit above, it's like King's 16K UHD, so it's not 16 divided by 9 aspect ratio. In other words, there is no such a real 16K UHD like that. Toria, real 8K UHD. What is real, buddy? There's different aspect ratio. So he even didn't know what he was talking about. But over UHD King, you're learning the real deal. By the way, we went into like arguments with Toria. We couldn't agree who was the first. I was the first based on my videos, but he was kind of playing and like he's smarter. But I'm the smartest because I'm a software developer, I'm a game developer. Most likely who's watching my content know who's Toria. Tell him that UHD King is much smarter when it comes to higher resolution in his video comments. But anyways, XYZ 3D coordinates, 16K video resolution, which is 16,384, can be width, height, and depth at the distance. All right. But 2D 32K resolution. All right. So this is for the Vulkan API. Right, let me show you OpenGL API, another open source, great, one of the famous 3D rendering real-time APIs. As again, this is 3D rendering real-time APIs. I'm not talking about not real-time APIs. Those can go above 16K video resolution rendering, but not in a real time. We're talking real time. XYZ, guys, 16,384, the same thing. 32K video resolution has a texture, but 3D world, 3D canvas, 3D surface, 16K video resolution. Not 16K UHD, but 16K video resolution. Alright, so GPU, CUDA, Nvidia CUDA. This is Nvidia CUDA. This is the people that develop the GPUs. They like know, like Jensen Huang, Nvidia and founder and the CEO of the Nvidia, is the best guy out there. Sometimes I'm thinking he's smarter than Elon Musk because he's such a computer scientist, such a brain, one of the greatest computer scientists ever alive on the planet. Because the Jensen Huang, Nvidia CEO and founder, we discovered so many technologies out there because of single guy. Okay, so check it out. 16K video resolution, 3D texture size, but 2D texture can be way above that. 32K resolution, same deal. See that? See that? Maximum 3D surface under the Nvidia CUDA surface, it's called 3D surface. Sometimes called 3D world, sometimes called 3D canvas. It depends, as again, what kind of APIs you're using for your 3D rendering real-time API. But this is Nvidia, guys, right? Let me show you direct OpenGL. But direct 3D, you know about direct 3D. I already showed you direct 3D. OpenCL. I showed you the OpenGL. This is the OpenCL, another great open source 3D rendering real-time API that does a lot of things besides the 3D rendering real-time API. Check it out. 16K video resolution XYZ, same deal. 32K video resolution 2D texture. The same thing, guys. The same thing over and over and over again. So that's why 16K video resolution is the maximum video resolution when it comes to PC gaming. Because when it comes to 3D rendering, 3D canvas, 3D surface, I know you can manipulate it, like make it 2D texture, but it's not going to be the real 3D world. Keep that in mind, all right? I'm telling you this as a software developer, game developer with over 10 years of experience, guys. And by the way, in the future, we'll be developing the games together over UHDking.com. This is another reason why you want to smash that subscribe button, smash all the bells, and share it with your friends, and be the follower, guys, all right? So that, guys, that's pretty much it. Don't forget to smash that like button. A lot of time, money, energy is invested. You learn just tons by watching a single video. More to come, more great videos, more gaming under 8K, 10K, 12K, 12K, 3, 8K in vertical mode, including the 16K video resolutions coming up. Some Photoshop tutorial, 3D animation, 3D modeling tutorials, all kind of great videos that are going to provide a lot of value into your life coming out to UHDking.com. Smash that subscribe button, like it, and I will see you guys till the next time. And you know exactly why UHD King, or I play 4K, AK, I play 8K, AK, I play 16K. You know exactly why I play 16K. Go ahead and check out my project. Check out SLIready.com. Check out SLIreadygames.com. Great channels, great projects for the people that looking to have the information about custom SLI profiles that definitely going to work. A lot of information will be provided with 2, 3, and 4 NVIDIA video cards that supporting SLI, how to activate that, how to utilize them at the best possible ways over those projects, YouTube projects by UHD King that you don't want to miss. Thank you so much for watching. As again, the audio track throughout this background was all rights reserved. Patrickus, beyond, and it was playing in real time, by the way, and my voice was a little bit disturbed because I was using some artificial intelligence, but it wasn't the GPU artificial intelligence that going to eat up some FPS in result. It was CPU artificial intelligence was removing some noise because my case is open, and those two Titan RTX are generating some noise. They're like single Titan X Maxwell GPU architecture, single fan. It was very noisy, but not as four of them. Four of them was like a jet. Go ahead and check out 4 Titan X Maxwell GPU architecture and SLI, and 4 Titan X Peace and SLI, the older video cards Titan X's, over UHDking.com. Check out my 4 Radeon Pro Duo Crossfire, quad Crossfire, like 4-way Crossfire, unbelievable video, Crossfire X over UHDking.com. A lot of information for PC gamer. If you're PC gamer, UG King should be on your list. Not one of those copycats. Unique computer scientist, technologist, gamer, software developer, 3D artist, graphics designer, so much system engineer, senior system engineer. I saw the computers that, like, I have the quantum certification, guys, and the quantum computer. Quantum computer is not what they talking to you guys. Not like that crazy alien stuff. No, it's just simple thing using. It used to use the tapes to store the data. I have, it's like robots inside, like robot arms moving and such. I have the quantum certification as a senior system engineer on that. A lot of information will be shared with you guys. Thank you so much for watching. As again, it was playing in real time, as you can see, beyond Patricus, all rights reserved, no royalties can be claimed. And yeah, I will see you guys till the next time. Have a good morning, have a good day, good evening, good night, till the next time.